In this video, we're going to talk about factoring polynomials. We're actually going to take two videos to talk about all the different ways to factor. And so maybe the first thing we should do is talk about what it means to factor. So the idea of factoring is really we're going to be reversing multiplication, which means instead of multiplying two things together, we're going to take what would be the result of that and break it back apart into two parts that would be multiplied. And those two parts, usually pieces that are multiplied, are called factors. So in the last video, we talked about distributing our monomial and multiplying it to each part. In this video, we're going to take the results for this type of factoring. We look at what they have in common, and we're going to break it back up into two pieces, and these two pieces are multiplied together. I like to break my factoring up into four categories. And so we're going to start with those categories now. The first of those categories is the greatest common factor. The greatest common factor is greatest, so the biggest thing that these terms share. Your book takes a lot of time to develop the idea of the greatest common factor, so you could definitely go in there and kind of work your way up to this if that's something you need to do. So I'm going to start with one example where we're just finding the common factor, right? We're not factoring it. We're just looking at what these three terms have in common. And we want to look at both the numbers and the variables. So let's start with the numbers. We have 36, 28, and 12. We are looking for the greatest or the biggest number that divides into each of these, all three of them, evenly, right? So I want a number that's a factor of 36, 28, and 12, all at the same time. So we could think about that for a minute, right? Sometimes 6 comes to mind because we know 36 is 6 times 6, and we know 12 is 6 times 2, so these two would share a factor of 6. But 6 does not divide evenly into 28, and so that wouldn't work as a common factor for all three. But 4 would, right? 4 times 9, 4 times 7, and 4 times 3. So 4 would be the greatest common factor for the numbers. Then we would look at the variables. We want to list any variables that they all share. Right? So if I look at each of these, they all have at least one x. This has one x, this has one x, this has three x's, but these only have one. So as far as what they have in common, they all have one x in common. The last term here has some y's, but these others don't, so they don't share it. So 4x would be the greatest common factor. Okay, let's try that same thing here with these two terms. Right? If you need to, think of there being a 1 in front of this one. So as far as the numbers, do 4 and 1 share any common factors? And I think the answer to that is no. So if they don't have anything in common, they always share a 1. So you could think of it being a 1. I'm not going to write the 1 because we usually don't do that. Although you could, it wouldn't be incorrect. So now let's move to the variables. How many x's do they share? They both have at least 2 x's. How many y's do they share? They both have at least 2 y's. So this is the greatest common factor, and we usually put it on the outside of the parentheses. And when we do that, because we're going backwards with multiplication, we're reversing, right? Essentially, we're going to divide each of these terms by what's the common factor. And we're going to list what's left from each term in the parentheses. So if I do 4x cubed y squared divided by the common factor, 4 divided by 1 would be 4. X cubed divided by x squared is going to leave me with 1x. That doesn't get canceled out. Y squared divided by y squared, those are going to cancel. Right? This term, 1 divided by 1 is 1. X squared divided by x squared, those are going to cancel to be 1. Y cubed divided by y squared is going to give me 1y left over. Okay, and you can always multiply this back out to check yourself. Why don't I do that in a different color? So if I multiplied this back out, this is my answer. Okay, so to check, this is supposed to be green. I don't know if you can tell that. X squared y squared times 4x would give me 4x cubed y squared. And x squared y squared times y would give me x squared y cubed. So when I multiply it back out, I get the originals, so I definitely did it right. Okay, but let me emphasize that this is our final answer. And we just did this to check ourselves. How about one more? Negative 8z to the 5th minus 24z to the 4th. So negative 8 and negative 24 share what common factor? Lots of common factors, but the biggest, I think, would be an 8. Since these are both negative, it's a good idea to go ahead and make the greatest common factor, the GCF, negative. So they both share negative 8. How many z's do they share? Z to the 4th. So if I divide by z to the 4th, what's left here unaccounted for is 1z. And here, this is going to be a plus because I'm dividing, and negative divided by negative would be a positive. Positive 3. And I've already accounted for all the z's. I won't take the time to multiply this one back out, but you could do that if you wanted to. Okay, so this is called the greatest common factor. I always list this one first because it's a really good first step when you're factoring. Usually if there's more than one type of factoring, very often it's a greatest common factor. And the greatest common factor, if it's done at the very beginning, can make the rest of the factoring steps a little bit easier. Okay, the next type of factoring is factoring by grouping. We're going to use factoring by grouping when we have 4 terms. So if we look at what we're trying to factor, if it has 4 parts, that's kind of a clue to us that, okay, I know what strategy to use. I want to use factoring by grouping. And this is how it works. We're going to group the 4 terms into pairs. So I'm going to pair them up, and then I'm going to factor out the greatest common factor in each pair. I really could have written GCF here because it's that idea. Okay, so once I do that, I factor out what each pair has in common. This is going to leave me with like 2 big looking terms, right? Each of them has a greatest common factor and a parentheses, right? 2 of those. So usually what's in common, if factoring by grouping works, the parentheses part is going to match up. And so we're kind of doing the GCF in 2 phases. Right? We did the GCF of each pair, and now between those 2 giant terms, this parentheses is also a GCF, and so we're factoring that out. Let me show you what I mean. Here's an example. I always like to start with this one because you can already begin to see some of the patterns that are going on right here that can be found when you're factoring by grouping. So we're going to pair these up. You are allowed to move the terms around. Any sign is attached to the term behind it. But I can move them around if I like. In all honesty, I've never really found a huge advantage in doing that, so I don't usually do that, but you are able to do that if you think it would make it easier for you. Okay, so what do the first two terms have in common? They both share an A, so that's the GCF. So I'm going to factor that out. From the first piece, I'm left with an X. From the second piece, I'm left with a Y. How about for this second pair? What is the GCF? It would be a 6. So I'm going to factor that out, and I'll have an X left and a Y left. Okay, these are those two big terms I was talking about. Here's one, plus here's the second one. So what do these two big terms have in common? They both have an X plus Y. So now I'm kind of doing the GCF again, and I'm using the parentheses as my common factor. So they both have an X plus Y. So I'm factoring that out. From the first big term here, I have the A left over. From the second big term, I have the 6 left over. And so it factors just like this. Okay, let's try another one. I want to do the same thing here. I want to pair them up. So I'm going to pair up the first two, 6x cubed minus 15x squared. And I'm going to pair up the second two. Anytime I have a minus in the middle, I want to shuffle that into the second pair and put a plus in between. Subtracting this 4x is the same as adding negative 4x. And so I'm using that to help me out here. So I'm going to put a plus in the middle, and then I'm going to make this negative 4x plus 10. The reason for doing that is I don't want to put a negative outside the parentheses, because if I do, I'm saying that I have factored it out. Usually in this first step, I'm not quite ready to do that. I'm going to do it eventually, but I want to do it when I'm ready. And usually this is not a good time to start yet. Okay, so now I want to look for a GCF for the first pair. What is that going to be? 3 goes into both of those, and they both share 2 x's. I'm going to factor that out and divide. What's left here is a 2 and 1x. And what's left here is a minus 5. Then I want to factor out the greatest common factor between the second pair. That's going to be a 2. Because I really would like the parentheses to match, I'm going to go ahead and use a negative 2. If I factor out a negative, it's going to change the sign of what I have left over. So negative 4x divided by negative 2 is going to leave me with a positive 2x. Positive 10 divided by negative 2 is going to leave me with a minus 5. And that's good because I need the parentheses to match in order for grouping to work. So now these two big terms both have a 2x minus 5, so I'm factoring that out. And I have a 3x squared left over from the first piece and a minus 2 left from the second piece. I have one more example for this. If you want to, take a second, pause the video, and see if you can work this out on your own. Okay, once you've come back, I'm going to work this one out just like we did the one above. So I'm going to pair them up. I'm going to put a plus in the middle and shuffle the negative into the second pair. The GCF between these two terms is x squared. When I divide out the x squared, I'll have an x and a minus 3. These two terms share a 5, and I'm going to factor it out as a negative 5. So negative divided by a negative is going to leave me with a positive x. Positive divided by a negative is going to leave me with a minus or negative 3. Now both terms share an x minus 3, so I'm going to factor that out. I have an x squared left from the first term and a minus 5 left from the second term. Okay, so we've looked at the greatest common factor. We've looked at factoring by grouping. I think the next section in your textbook looks at factoring trinomials, which would be polynomials with 3 pieces. Usually these look something like this: ax squared plus bx plus c. So when I factor this, and usually if you think of factoring, this is the type of factoring you think of first. This type of factoring is taking the result that looks like this and kind of doing FOIL, thinking about FOIL in reverse, right? FOIL is the process where we take 2 binomials in parentheses and we multiply them, right? And so we want to kind of use the logic that we use for FOIL to work backwards. So I always like to do this example as a starter because there aren't a lot of choices, right? So it can kind of help you think about going backwards. So we just looked at FOIL in the last video. And so the first times the first is what gives us x squared, because we need a variable in each parentheses. If we didn't have a variable in both, then we'd have to have a GCF here, and we don't. So we need a variable in both parentheses. To get the 2, I need 2 numbers in the back that multiply to be 2. I always start with this one because there's only one possibility, right? It has to be a 2 and a 1. There aren't any other options. Okay, and then to make sure that this works, these numbers in the back also need to add up the outside, x times 1, and the inside, 2 times x, need to add up to 3x. And they will if they're both positive. Okay, that's a basic summary of what's called the trial and error method, where we try things, right? We make our 2 parentheses and we try things out. So if we have something that starts with just x squared, no number in front, no a, or a is 1, it amounts to finding 2 numbers that add to be b and multiply to be c. So let's try that out. Let's say we had x squared plus 7x plus 12. If I wanted to try the trial and error method, I know I need to have x and x. So I need 2 numbers in the back that multiply to be 12 and add to be 7. You can think of all the possible factors of 12, right, or factor pairs. I think the one that's going to work is 3 and 4. 3 times 4 is 12, and 3 plus 4 is 7. And I need a positive 7, so I want these to both be positive. Okay, I have several here, so let's try a couple more. How about x squared plus 8x plus 12? Again, I need 2 numbers that multiply to be 12 and add to be 8. This time 6 and 2 are going to work really well. it is a positive 8. So I know that I need a positive 2 and a positive 6. And I'm not doing this here, but you could FOIL this out, right? And multiply it back out and check yourself and see if you get this. Then you'll know that you did it correctly. Okay, how about the next one? I need two numbers that multiply to be negative 12 and add to be negative 4. This time we're actually subtracting because we have some interesting signs going on, right? So I can still do 6 and 2. In order to multiply to be negative 12, one of those numbers is going to have to be negative. So if I multiply these out, on the outside I'm going to have 2x. On the inside I'm going to have 6x. To make it add up to negative 4x, I need the 6x to be negative. And again, you could multiply that out and check yourself and make sure that works. I usually draw this, or sometimes I draw these little rainbows down here and write down the 2x and the negative 6x, whatever helps you keep track of what you're doing. There are many methods to factoring, so by all means, if your method works, don't change on my account. As long as you've got a good method going, I don't want to stop that. Okay, one more. This time we need two numbers that multiply to be negative 12, add to be positive 1. I think what we're looking for is 4x and 3x. Oh, I did that backwards. Okay, so same thing's true here. If I have a negative 12, then they're going to have opposite sign. Since I want a positive x, I need the 4x to be positive and the 3 to be negative so that they add up to be positive 1x. There are some patterns in the signs of what we see there, right? So if the last number is positive, then it turns out that the parentheses are going to have the same sign, either both plus or both minus. But if the last number is negative, then the parentheses are going to have opposite sign. And it turns out that the larger number is going to have the same sign as b. And that's really just so that you can add them up to get the middle. All right, here's one more. We're actually going to do this one with two methods. So I wanted to do this one with the trial and error method just to show you how it looks if there is a number out front. And then I want to show you something called the AC method, which is a little bit more systematic, and it makes use of the factoring by grouping. Okay, so first let me just point out there's no GCF here, right? 2, 7, and 3 do not share any common factors. So there's not going to be anything on the outside of the parentheses. The first times the first must be 2x squared. So the only way that can happen is if one parentheses has a 2x and the other has an x or a 1x. Right? And so this makes this example different from all the other ones that we just did because it's not just x and x. And what makes it different is now the parentheses are not the same, right? So where I place these numbers in the back, it makes a difference now. On the examples we just finished, it didn't matter which number we put where because the front was the same. So we could always move them around. It doesn't matter which order you multiply in. But here, the number I put here, when I calculate the outside, is going to get multiplied by the 2x. The number I put here, when I calculate the inside, is going to get multiplied by x. Okay, in this example, I need two numbers in the back here that multiply to be 3. So really I only have one choice for this one, 3 and 1. So the question is, where should I put the 3 and where should I put the 1? And I need to do it in such a way that I can make this add up to 7. If I put the 1 here, I'll have 2x times 1, or 2x. I'm going to write it off to the side. And that would mean I would have to put the 3 here. 3 times x would be 3x. But this is not going to add up to 7x, right? Even if I adjusted the signs, it's not going to work. Okay, and that was if I put the 1 here. So that's not going to work. So it must be that I need to put the 3 here. 2x times 3 gives me 6x. Put the 1 here. 1 times x gives me 1x. I can make that work. If I add them up, they add up to 7x if they're both positive. Let me do this so you can see the answer better. Okay, so it's a little bit different process because the 2 plays a part, right? 3 and 1 in and of themselves do not add up to 7, clearly. So to make this work, the 2 has to be part of the process, and that's what makes this problem different than the others. Let me take a second to show you the AC method. So the idea behind the AC method is instead of doing the trial and error, we break up this middle term so that we will then have 4 pieces and we can use factoring by grouping. Okay, so the A and the C come from what we had up here earlier. I'll write it down one more time. Come from this. So the A here is 2, the C would be 3. So A times C is 6. What I usually do is list all the factor pairs of 6 off to the side. 6 is a kind of a small number, so I don't have a whole lot of choices. But now these are numbers that multiply to be 6. Now I'm choosing the pair that add to be 7. Okay, so once I've identified those two numbers, then I'm going to break up 7x into 1x plus 6x. And then I'm going to factor by grouping. Since I have a plus in the middle, I'm just going to go ahead and throw on parentheses so I don't have to write an extra line. The GCF for the first pair would be x. The GCF for the second pair would be 3. Now these two giant terms share a 2x plus 1. We have an x left from the first part and a 3 left from the second part. Notice this is the same answer we got when we did it by trial and error. Let's try one more of those. A times C this time is 24. So if I list the factor pairs of 24, I usually go in order. So I have 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 doesn't go in. The next number would be 6, but I already have that listed here, so now I know I have them all. So which of these pairs can I make add up to be negative 11? It's definitely 3 and 8, but I'd need to make them both negative in order for that to work, which I can do. So then I'm going to rewrite this as 4x squared minus 3x minus 8x plus 6. Notice I haven't changed the polynomial, I'm just rewriting it in a different way. Now I'm going to pair them up. Notice I shuffled the negative into that second pair. The first pair share an x, so I'll have 4x minus 3 left over. The second pair share a 2. Since this is a negative 8, I'm going to make it a negative 2. When I divide by negative 2, this becomes positive 4x minus 3. Now they both share a 4x minus 3. So I'm going to factor that out. And I have an x and a minus 2 left over. All right, that was a lot of factoring in this video. So we did 3 categories, maybe 2.5. We're going to continue this third category in the next video and add in the fourth category. So definitely take some time to practice each of these factoring methods. And it's good to know when to use which method. I hope we've kind of talked about that. And how to use each method, right? So the when and the how are really important. All right, well, good luck. We'll see you in the next video.